let's solve another problem. So now this is on shear. So a brass plate of an outdoor sculpture experiences shear forces due to an earthquake. So the plate is 0.8 meters square and 0.5 centimeters thick. So first we draw the plate. So it said that it is square and it is 0.5 centimeters thick. So we have a square here of 0.8 meters and we have a thickness of 0.5 centimeters. So I suppose this is a sort of a support for the sculpture. So let's say this is the sculpture. Now, what is the force exerted on each of its edges? So these are the forces. For example, the earthquake causes a shearing force on these sides. What is the force exerted on each of its edges if the resulting displacement is 0.16 millimeters? So this 0.16 millimeters is actually this length. So let's call that x. Right, so what are the forces exerted? So let's write our equation. So S is stress over strain. And we know we can find the force inside this stress. So let's rewrite this equation. We solve for stress first. This is strain times S. Okay, so the thing is, S is already known. It is already readily available for different kinds of material. So for example, our material is a brass base plate or a brass plate. So it already has a value for the shear moduli. So we can compute for stress to be, now strain is x over h, and S, if you look up on a table, you will see that this is 7 times 10 to the 6 pascals. Now what is x? So x is 0.16 millimeters. So 0.16 millimeters, so times 10 to the minus 3 meters. And h is, if you would recall, that is the original height. So since this is a square, its original height is 0.8 meters. So this is 0.8 meters. So plugging in the values, we would get the stress to be equal to 7. S, this should be this should be the elastic moduli 3.5 times 10 to the 10 pascals. So this, sorry for the mistake earlier, this is the elastic moduli, the shear moduli for the brass plate. And the answer should be, the stress is 7.0 times 10 to the 6 pascals. Okay, so now we are actually to solve for the forces. So we know that stress is just equal to the force applied parallel over the area applied. So our parallel forces will be equal to the shear stress times the area. So our stress is 7.0 times 10 to the 6 pascals times, so the area on which the shear force is applied is what do we have, 0.8 times 0.5 cm. So we have 0.8 meters times 0.5 cm. So this is cm. So we should have the force of the earthquake to be 2.8 times 10 to the 4 newtons. So this is actually 1, 2, 3. Another 0. So this is 28,000 newtons.